All right, so today we're starting Unit 4, which is a lot of geometry review. Specifically, we're going to be talking about parallel lines, triangles, and some relationships between them all. Now, this section is really a review of a lot of concepts you've already learned. So we're going to go through them kind of fast. You've seen them before, you know the relationships. I think you just need a reminder of them. And then, of course, in the end, we're going to take these relationships and we're going to start mixing them together. I was going through ACT questions looking for examples that would be good ones to use as we talk about this homework and this unit in class. And just 4.1, I went through, I think, 3 practice tests. And I found, without even looking that closely, I quickly found 7 different ACT problems that all require one or more of these ideas. And a lot of times they actually take 2 of these concepts and they put them together into one problem. So what we're going to do today, I'm going to remind you what these individually are, what these different rules and things that you've learned in the past, and then we're going to start combining them together where you're going to have to problem solve and start figuring out what you know about different situations and apply that to a bigger problem. So starting at the beginning, parallel lines with a transversal. So remember, parallel lines are lines that run, it kind of like they run exactly in the same direction. They never cross. So there's a bunch of examples down below. You've got parallel lines that run in the same direction without ever crossing. That makes them parallel. Now, one way that we denote that in math, you'll notice a lot of these parallel lines have this little arrow on them. That tells you that this line is parallel to this line. That's what that little arrow on the line means. This line that crosses the parallels, this, let me mark it here for you. This red line that crosses the parallels, this is what we call a transversal. It transverses the parallel lines. If I had another line on this diagram and it was parallel to the transversal, instead of having one little arrow on each, we could put 2 arrows on each to say that those 2 lines are parallel to each other, and these 2 yellow ones are, where did my yellow pen go? These 2 yellow ones are parallel to each other. So remember that notation, and hopefully that's something you've heard before, right? Hopefully you've heard that parallel line and transversal. Sometimes they'll try to rotate the pictures on you. It'll look exactly like this. It'll just be rotated so that the parallel lines are running in a different direction. But the rule is still the rule. So it's important to know what's the transversal and what the parallel lines are. Now, in this same diagram, we've got these 2 angles right here. I'm going to label these. I'm going to call this angle A, this angle B. Now, notice both of these angles are marked with this little circle, this little part of a circle. Now, that tells you that those angles are the same. Now, there is a little bit of different notation. Sometimes these little part circles, these curves will have a dash on them. But a lot of times you'll just see, instead of having the dash, they'll just say, this angle is congruent to this angle, and they'll only have one line. If they wanted to show you another set of congruent angles, they could use 2 lines like this to say these 2 angles are congruent. Or if it's a book or a problem that doesn't use the multiple lines, they might say something like, okay, this angle and this angle, and they'll mark it with 2 tick marks instead of 2 curves to show you that they're congruent. Just make sure you understand that's what these little tick marks mean. This angle and this angle are congruent. Now, back in, 7th grade, you learned about alternate interior angles. Alternate interior angles are on the interior of the parallel lines. So they're in between the parallel lines. That's where the interior comes from. Alternate means they're on alternate sides of the transversal. And they are congruent. This symbol right here, remember, means congruent. It's kind of like saying equal, but in geometry, we don't usually use the word equal when we're describing a length or a part of a shape. We usually use the word congruent. We're a little bit, if you were to put equal on the homework or on a paper, I'm probably not going to mark it wrong, but I don't want you to panic when you see that symbol. It looks a lot like the equal sign. So alternate angles are congruent. This angle and this angle are congruent to each other. That also means that this angle on this side and this angle on this side are congruent because they're on alternate sides on the interior of the parallel lines. All right, next image, alternate exterior angles. So you've got your two parallels, you've got your transversal, and now we're saying that the alternate exterior angles, so they're on alternate sides of the transversal and they're on the exterior of the parallels. So this angle and this angle are congruent. That also means that this angle here and this angle here are congruent with each other or congruent to each other. Probably should use the right language as we go here, right? All right, corresponding angles. These ones are on the same side of the transversal, but one is inside the parallel lines and one is on the outside. So I think this is the easiest one to see because you see this angle and they just look the same and they're right close to each other. So it's easy to say that this angle and this angle are congruent. And maybe it's not easy mathematically to prove it, but it's visually, it's easy to make that assumption that those are probably going to be equal to each other. Consecutive interior angles add up to be 180 degrees. So if you take the interior angles on the same side of the transversal, they're not the same as each other. And if you look at the picture, they're definitely not the same. This one is a lot smaller angle than this one. But those two angles add up to 180 degrees. Now that red angle is congruent to this angle on this side, and the blue angle is congruent to the blue angle over here, which means that those two are also adding up to 180 degrees. And this is kind of a cool picture, and it helps you see where they came up with these rules because this blue and this red make a straight line. And we know that a straight line is 180 degrees. So if a blue and a red add up to 180, it doesn't matter where those two angles are, they still add up to 180 degrees. All right, what else do you need to remember? Pythagorean theorem, we've reviewed this quite a bit already this year, so we're not going to spend too much time on it. A squared plus b squared equals c squared. Please remember this only works in a right triangle, and it is absolutely crucial that C is the side that is across from the 90-degree angle. Okay, C squared comes from C, which is a cross from the 90. The A and the B you can switch around, no big deal, but C has to be the side of the triangle across from the 90. Triangle sum, another one that we've used this year and one that you guys are pretty good at. It's one that you tend to remember. The three inside angles of a triangle add up to 180 degrees. We're going to use that one a lot in conjunction with other problems. But that rule is always going to be true. A little vocabulary, isosceles triangle is a triangle where two of the sides are congruent with each other and two of the angles are congruent with each other. And you'll notice on this picture, if this side and this side are the congruent sides, then the angles that go with them, the angles that are across from those sides might be a better way to put it. This angle is a cross from this side, and this angle is across from this side. And since the angles are the same, the sides are the same, and the other way around. Because the sides are the same, Those two angles are the same. And that leaves this angle at the top and this side of the triangle alone. They don't match anything else in that diagram. Other angle relationships, linear angles are angles that form a straight line, and those add up to 180 degrees. So you've got this straight line right here, and if you break it into two angles, the angle on the left and the angle on the right add up to be 180 degrees, which is kind of a no-brainer because when they're side by side and you connect them, they make a straight line, which you know is 180 degrees. Vertical angles, another one that you usually remember, are congruent to each other. Now, these are angles that are straight across each other when there's an intersection. Now, this one's important because what the ACT will like to do is add another line right here. And when you're looking at vertical angles, a lot of times it helps if you like draw the line that makes the angle. So this line and this line are the two lines that I'm using, so the angles are in between those two lines. The ACT likes to try to goof you up and give you these other lines that are part of it, and you've got to remember that this angle isn't created by two lines that intersect. It's actually created by a bunch of different lines coming together because if I extend this line, it doesn't extend to anything in the picture. And if I extend this line, it does. But this angle isn't congruent to any other angle in the picture. So be careful on the ACT. Remember that the lines have to be straight across from each other when the angles have to be straight across from each other when their lines intersect. Then they are congruent. So let's do some examples. Now, these are going to mix, some of these are going to mix different concepts, different things together. And this is why I like geometry so much is you're doing math, but you have pictures to help you do the math. And that is a little bit intimidating for a lot of people. For me, I try to look at it as it's giving me something to help me do the math. I'm not just trying to deal with numbers and equations and formulas. I have a picture that I can look at and use to try to make sense of the math that I'm doing when I do my algebra and use my equations and formulas. So what we're going to be looking at today, if you look at the homework, you've got all sorts of different pictures. You've got this triangle with a line coming off of it. You've got two parallel lines with a transversal. You've got two parallel lines with a transversal, but the parallels are going different ways. You've got another triangle with a line sticking off of it. Here you've got intersecting lines, but there's 5 lines, not just 4. Here you've got another transversal. You've got a triangle, a right triangle in this picture, another right triangle, another right triangle. Here you've got 2 triangles stuck together. One's an isosceles, one's a right. So these pictures, a lot of them aren't going to just use one of the rules that you know. They're going to combine these rules together. And same with those ACT questions up that I showed you at the beginning. They're not always using just one idea, one picture. For example, that one right there is 2 different triangles put together. They make a parallelogram, which also means you've got 2 different sets of parallel lines. So it's going to combine your knowledge about parallel lines, transversals, right triangles, isosceles triangles, angles adding up to 180, straight lines, vertical angles. All of this is getting combined into one problem as we go. All right, so example A. You've got 2 parallel lines. That's the first thing I notice when it tells me to find X, Y, and Z. I've got these 2 lines that are parallel. And if I'm doing geometry problems, a lot of times I'll have colored pencils with me to kind of help me with my math, because I like to mark my parallel lines. I like to mark my transversal so that it's easy to know what I'm working with. So when I look at this picture, I need to find X and Y and Z, and I'm just looking for relationships. I'm using all of these relationships that I I covered it up above, and I'm looking for what's going to help me down below. And you might already see relationships that I'm not looking at. The nice thing about these problems is there's lots of different ways to do them. One of the first things I notice when I look at this diagram is I've got this straight line right here. And these two angles make that straight line, this 140 degrees and this angle Z. Well, the relationship up above told me that a straight line is 180 degrees. So that means if I take 140 and I add Z, I should get 180, which makes it really easy for me to come up with the fact that Z is equal to 40. So I've already found one of them. Now from here, lots of different options. What I like to do as I solve, now that I know what Z is, a lot of times I will put 40 degrees right here. Because now that I know that that's 40, it may help me solve other parts of the problem in another way. For example, there are multiple relationships in this picture that I can see now. I've got this angle and this angle. Those are vertical angles. They are straight across each other, which means they are congruent. They're equal to each other. I've got this angle right here and this angle right here that make a straight line. So those add up to 180 degrees. Either one of those is going to help me solve for y. I can either set them, do the vertical angles are congruent, or I can do these add up to 180. I'm going to do vertical angles since we did the straight line on the last one. So this 140 degrees and this y plus 75 are vertical angles, which means they are equal. So I'm going to write that down. 140 is equal to y plus 75. And it's a simple railroad track to figure out what y is. I'm minus 75 from this side. I'm minus 75 from here. And y is equal to 65. And you'll get the same thing if you had solved it the other way. If you solved it the other way correctly and I did it correctly, that is. If one of us did it wrong, then they're definitely not going to match. So now I know that y is 65. And I know that this angle is 140, which I can use. That's one of the ways I can solve for this missing piece. I'm looking for x, and now I've got the option, because I know that this angle on the inside right here is 140, I've got one rule that tells me that the two angles on the inside, this yellow one and this green one right here, they add up to 180 degrees. I also know that this angle and this angle are consecutive, or corresponding angles, sorry, wrong word there. This angle and this angle, one is inside, one is outside, and those are corresponding angles, which mean they're equal to each other. So I can either set this equal to this, or I can say this plus this equals 180. Let's go ahead and use the corresponding angles. I'm going to say that x plus 23 is equal to 40 degrees. I like that one because the numbers are small. I don't have to use 140. To figure out x, I'm going to minus 23 from both sides. And that means that x is equal to 17. So the angle's not 17, but x is equal to 17. So when I plug it in, that angle is 40 degrees, which I want it to be, because 17 plus 23 is 40. If this is 40, that means this must be 40, which also means this must be 40, which means this must be 140, which means this must be 140. We don't need any of that, but once you start knowing pieces, it helps you find other pieces of the diagram. All right, let's go down. You know what? Let's do problem C next. Find the length of the unlabeled side. This one you can probably do pretty quick because we've done it already this quarter. or I guess not this quarter because today's the first day of the quarter, but we've already done it this year. This is a 90-degree triangle, which means I can use a squared plus b squared equals c squared to find this missing piece right here. Across from the 90 is 26. That means c is 26. And I can call this a or b, and this can just be whatever is missing, the other one. So a squared plus b squared, and since b is 23, it's 23 squared equals 26 squared. Now, if you have been paying attention to this formula over the last couple years that you've been using it, hopefully you remember not to just say a plus 23 equals 26. Okay, because you've got to remember to square the sides when you add them and set them equal to c squared. So a squared plus, I don't know 23 squared off the top of my head. That's not one I've memorized. 529 equals 26 squared. I'm just typing these in the calculator, equals 676. Now I can do my railroad track and get a squared alone. So I'm going to minus 529, minus 529. And after I do that, I get to use some stuff from, whoops, that looks like a2. A squared is equal to 147. Now, I want to square root both sides to get a alone. So a is going to equal, I don't think that's going to be a nice number, is it? 7 root 3. Or if I use my best friend button, I'm going to get 12.12. Let's go 3 decimals, 12.124. Now, theoretically, when you were taught last chapter, when you square root doing railroad tracks, you also will get negative 7 root 3 and negative 12.124, right? You get 2 answers. Because A is the length of a side of a triangle, we are going to go ahead and ignore that answer. Even though technically it solves the equation, in the context of a story problem or a geometry problem where the length is always going to be a positive number, we've got to use the positive answer on that problem. All right, let's go over here to problem B. That's a little confusing. Problem B, example number 3, whatever you want to call it, or 2, because I guess we skipped this one. Now, this is one where we're going to take multiple concepts and apply that into one problem, okay? First thing I notice is I have a tick mark on both sides of this triangle, which means those sides are the same, and it also means that the angles across from those sides are the same. So if this angle on the bottom is A, that means this angle on the bottom right is also A. So both of those angles are A, so they're going to be equal to each other. And I can actually figure out what those are because I know that the 3 angles of a triangle add up to 180 degrees. So 56 plus A equals 180. When I simplify that, I get 56 plus 2A equals 180. And now I can just do some railroad track stuff. I can minus 56. So 2A is equal to what? 124. And then I divide by 2. A equals 62. So now I'm going to go up here to my picture, and I'm going to actually change this to 62, and I'm going to change this to 62, because that might help me solve the next part of the problem. I don't really know anything about these two in relationship to each other, but I do know I've got a straight line right here. So that means if the left angle is 62 degrees, then when I add that to B, it's a lowercase b. when I add 62 to B, I should get 180 degrees because this is a straight line. So all I have to do is minus 62 from both sides, and I get B equals, 118. So I can scribble that out and call this angle 118 degrees. So I found A, I found B. Now I need to find C, and there's multiple ways to do this. You might already be working on, in fact, you could have found C before you found B using a little bit of math with the angles of a triangle adding up to 180. I see this triangle right here, this blue triangle, and I know that the angles add up to 180, and I've found two of the angles already. So it's really easy to figure out that third angle because I just take my 180 degrees and I minus the 30 and I minus the 118, and that's going to give me the third angle of the triangle. So 180 minus 30 is 150, minus 118 equals C. 150 minus 118 is 32, which equals C. So this angle is 32 degrees. C is equal to 32. All right, your turn. Down below, you've got a bunch of different pictures, a bunch of different relationships. All of them are connected to what we did in our review up above. All the relationships that you need to solve the problems below are up there at the top. So work together. Make sure you are seeing and learning how to solve these on your own because these are problems you will absolutely see on our quiz, our test, and obviously the ACT because I found a dozen examples of them without trying very hard. So time's yours. Let me know if you need help.